Yeah, I'm kidding.
Okay. So quarterly means 4 times, annually means once, semi-annually means twice, monthly, how many times a year is monthly? 12. I mean, you should write it down unless you know it all. Daily means 365. Good.
We are not going
Claudia,
that
you
far.
need to stop singing. I'm teaching. Okay, so now we have a bunch of formulas. The first one is compound interest, and you'll tell by the word problem because it will say, what is the compound interest? So it will be very obvious which formula you need to use. In this, the compound interest formula, A is the total amount at the end of whatever time period that you're creating or developing interest on. Yes?
On the test, will we have the formula sheet?
No. Okay. So P is your initial amount, your principal amount. How much did you start off with? Right? R is the rate. N is the number of times each year. And T is the time. All right, the next one, continuously compound. Oh, you guys, you have this all written down already, guys. I gave you the formula sheet in the thing. You like to write it down? Sure.
Why are there two n's, one in the denominator and one in the exponent?
They both represent the same thing, right? Doesn't the same variable represent the same thing?
So they both are a number of times each.
Wait, what's the exponent?
NT.
Wait, so X is fine, is compound.
Yeah.
Oh wait, wasn't this on
Yeah, we're gonna have
Wait,
Yeah, NT.
NT in the exponent?
NT in the exponent.
It's in both spots.
Yeah.
I think I got it right. What do you think?
Per.
Okay, the next one is continuously compounded. And like I said, it will be very obvious in the word problems which formula to use because it will say continuously compounded. So for this, again, A represents the total amount at the end. P is our principal amount, whatever we started off with. E is E. And then that exponent is RT. That exponent is RT. So this is A equals PE RT. So R is the rate, T is the time. E is E.
So you just leave E there?
Yeah, like E is,
2.7, that one?
yeah.
Are those things in the top right, like different values for n based on like?
There's no N here. This is R, this is, yes. So based on your word problem, it's going to tell you different amounts for all of these variables, obviously except for E. Okay, the next one, I'll rewrite it, is N equals N sub 0 times 2 raised to the negative T over K. That's a negative. Negative T over K power. N equals N sub 0 times 2 raised to the negative T over K.
What is that? What is sub-zero?
Our initial amount. So N is the amount at the end. N sub 0 is the amount at like 0 start time before we even start any decay process. T is time. K is the determining half-life factor. And this will mean more once we start doing problems.
That's like science. We had one of those on the.
This is science.
Yeah,
DK is
this
science.
This is on the engineer SLA. There was a question about
This is
About-
the first
about
test of the year, remember?
On the first test of the year?
Why are we doing chemistry?
Okay, can we get started?
No, Miss, I didn't get it. Wait.
I mean, it's like 3 letters written down. I don't.
No, I need to write down all the definitions.
Oh, okay.
Is it 2 to the T over A?
2 raised to the negative T over K.
You see an A variable?
So blurry.
Just read.
This is blurry,
That one, no, I was looking at the other.
but I rewrote it nice and big for you.
I didn't see that.
That was a whole point.
Can you go back to
Okay, go back. I missed your definition.
I don't cheat in the house.
Yes, you do.
Why is there one?
I see you all the time.
No, this is RT. This is RT.
No. They tell you the answer.
It looks like an N.
Wait, is it negative T?
Negative T.
But it doesn't say negative in the...
Yeah, it's just attached. Guys, this. Just write down what I'm writing. That's it. It's not really this is not that big of a deal. This should not be this complicated writing down the formulas I wrote down.
It's that complicated.
It's a lot of definitions.
We good?
Yeah.
Good, Dylan? Not yet?
Yeah.
You got it? We're good? Yes? Okay. So first word problem. I am not going to wait for you all to write down all the word problems. I'm sorry. It's not going to happen. That's why I posted the word problem sheet there. You write down the work, but you don't have to write down the word problem. All right, so how long does it take $1,000 to amount to $1,500 if it is invested at 8% compounded quarterly? Compounded quarterly. Did it say continuously compounded? No, so it just said compounded. So which formula do we use? The compound interest formula. And the compound interest formula is A equals P times the sum of 1 plus R over N raised to the NT power. All right, so how long does it take $1,000? Do we all agree that's our principal amount? That's what we're starting with? So out of all these variables, which variable represents what we started with? P. And then it says to amount to 1,500. Do we agree that's the amount we want at the end? So out of this whole formula, which variable represents the amount we want at the end? A. So I'm going to start plugging in. We are 1,500 equals 1,000. Open up my parentheses. All right, R is the rate. So it says if it is invested at 8% compounded quarterly. So do we all agree the rate is 8%? But I want to take that percent and I want to write it as a decimal. So how is 8% written as a decimal? 0.08. Good. 0.08 over the amount of times each year. So it says compounded quarterly. So how many times is that each year? 4. Raised to the NT power. So isn't that 4t? And it says how long, right? How long? So we obviously are solving for time. How long does it take? Are we ready to go and solve this?
Yeah.
All right, so this is all calculator. So because this is all calculator, it shouldn't be that bad. So I'm going to start off, we obviously need to solve for t. So I'm going to get the expression that has the t in it completely by itself. So where do you think I'm going to start here? Divide by 1,000. When I divide by 1,000, I am left with 1.5 equals. Now, if you wanted to simplify this, could you? This whole thing, could you just put that into your calculator? Yeah, you could. If you wanted to just leave it like that, could you? Yeah, absolutely. I'm going to choose to just leave it like this. Right, now we need to get that 4t out of the exponent. How do we get it out of the exponent? Logs on both sides. So now I'm going to have log 1.5 equals 4t log quantity of 1 plus 0.08 over 4.
Can you just make that 1.1?
That's what I said. You can absolutely just simplify that down if you want. I don't really care. So now I'm solving for t. So in order to solve for t, I need to get it by itself. So what I'm going to do is I'm going to take log 1.5 and I'm going to divide it by 4 log quantity of 1 plus 0.08 over 4. And then I would just type that whole thing into my calculator. Let's do 3 decimal places. It's going to be 3 decimal places always, unless we're talking about money. Then how much should it be? Oh, so this, yeah. So it's 3 decimal places unless we're talking about money. If we're talking about money, how many decimal places should it be? 2. All right, so in your calculator, you're going to do parentheses, log 1.5, close your parentheses. So you need that numerator in parentheses by itself. Do you guys want to show me? I can't show you on the calculator because I'm recording, and then it will stop recording. So open your parentheses, log 1.5, double close your parenthesis there. Double close it. And then the division sign. And now open your parenthesis for log 1 plus 0.08 divided by 4, double close your parenthesis. So now how long is this approximately? 5.119 years.
Bless you.
Why do you have to do double parentheses in the numerator?
Because you're not just dividing. Technically, you don't have to, but I always like to do it in case there's multiple things going on in the numerator. It's just a good habit, I guess I should say. You don't have to.
Is it always going to be measured in years and time, or?
Well, it could be. I'm trying to think if I throw any curveballs in. I think I'm pretty straightforward in everything. All right, find the amount of money earned if $100 is invested at 7% for 20 years, compounded continuously. Do you see what I mean when I say it's very obvious which formula to use? I'm not really trying to trick you at all. So now if we're compounded continuously, our formula is A equals PE raised to the RT power. So it says find the amount of money earned if 100 is invested at 7% for 20 years compounded continuously. So $100, do we all agree that is our principal amount? So we're going to have A is equal to 100. E is E. Our rate is 7%. Change it to a decimal. 7% as a decimal is 0.07 times how many years for 20 years? And I would just put this right into your calculator. But since we're talking about money, we're not going to just follow the 3 decimal rule. We're going to make it 2 decimals. So this should be, did anybody get it?
405.52.
Yeah, you can put that right into your calculator. Does anybody want me to tell you how to put it into your calculator? Anybody having problems? All right. Can I go on to number 3?
Yeah.
All right. A radioactive gas has a half-life of 3.8 days. How long will it take 1 gram of the gas to decay to 0.2 grams? So exponential decay, right? So in the exponential decay formula, we have n equals n sub 0, that's our starting amount, times 2 raised to the negative t over k power. So it's saying how long will it take? So do you all agree that we're trying to find time? The t, we're trying to solve for t. So let's plug everything else in. It says our half-life is 3.8. Which variable represents our half-life? In this formula, k. In this formula, k represents our half-life. How long will it take 1 gram? What is our 1 gram? And 0. So we have 1 times 2 raised to the negative t over 3.8. And what do we want it to decay to? 0.2. So that's our n. Once again, I need to solve for something that's in an exponent. So what do I have to do? Log of both sides. So we're going to have log of 0.2 equals negative t over 3.8 log 1.2. So to start off in this problem, I would divide by log 1.2.
Wait,
So,
isn't it just 2?
is it log? Oh, it's just 2. I'm sorry. That one is no purpose of it. 2. Thank you. So I would divide by log 2. And then I would then multiply by a negative 3.8 on both sides. So negative 3.8 log 0.2 over log 2. If you wanted to just put that negative 3.8 in the numerator, it's the same. It doesn't matter. Equals t. And since this is not dealing with money, we're going to do 3 decimal places. So it's going to be, anybody put it into the calculator? 8.823 days.
So we're doing years, you put years.
You have to put a unit or else you'll use
It's not bad. I told you it wasn't bad. All right, last problem. Of the day. Of the year.
Yo, it's about radon.
You do have homework. All right. Last problem for me. All right, the half-life of radon 222 is 3.8 days. How much of a supply of 1,000 grams will remain after 30.4 days? All right, so do we all agree we're finding the amount at the end? So we're solving for n. What's our initial amount? 1,000. And then how many days? The time is 3.8, or no, 30.4. The time is 30.4. And what is the decay? 3.8. I would just type this all into my calculator just like this. So n is approximately, give me 3 decimal places. 3.906 grams. You got it. Okay, kids, we're done. You could probably get your homework.